All right, to differentiate the natural log, what we have is a derivative rule that says that it's the derivative of the argument over the argument. Another way of thinking about this is that it's a prime over a, where a is your argument. Please note that when you look at the right-hand side of the derivative rule, there is no natural log in sight. So when you apply this natural log derivative rule, you are losing that natural log, and all you get is the derivative of the argument over the argument. All right, so of course the key question is, well, where on earth is the argument for this natural log? Remember that the argument is going to be whatever follows the first term that is immediately after the ln. So here, the first term that follows after the ln is 7x squared. So that is our argument. So you can always like superimpose parentheses or you can circle it, but when we take our derivative, our first step is we will put the argument in the denominator, and that's our a or argument that we're looking at. And then in the numerator, we take the derivative of what we just wrote down. So 7x squared becomes 14x when we take the derivative. Now you then need to simplify. So the 14 over 7 becomes 2. The x to the first over x squared will leave you with just an x in the denominator. So we have that this derivative will be 2 over x. All right, now if you look at the second example here, you'll notice that there are parentheses, and that means that all of this is the argument. So we will have, when we take our derivative, 3 plus x squared in the denominator, and then that's our argument, and then we take the derivative of the argument. So the derivative of 3 goes to 0, the x squared becomes 2x. Now, you'll notice that because of this plus sign in the denominator, addition is not going to be undone by division. So you cannot cancel out this x with this x squared. So this would be your final derivative. You would not simplify any further past that. All right, let's look at one more. So here you see that you have parentheses raised to a power. So that means whenever we have parentheses raised to a power, we need to start by using the general power rule. So we will start by bringing our 5 down, and then we keep the inside fixed. So we keep it fixed at natural log of x. Then we subtract 1 from the exponent. And then our third step is we multiply by the derivative of what is inside. Now, because the derivative of what's inside involves a natural log, when we see that natural log there, we say, okay, we have to take the argument's derivative over the argument. So the question, of course, is what is the argument? The argument, again, is whatever follows the first term immediately after the natural log. So this will be that the argument is x, so we put that in the denominator. And then the derivative of x, because it's a coefficient or linear term, we will just have a coefficient of 1. So that will be our derivative. Now, just like with our general power rule that we did before, usually something in the front, something after the parentheses can combine. So you could leave your answer like this, or you could combine the front and the end together. So that would give you 5 over x, and then the natural log of x to the 4th power.